In order to build your own 3D printed web-enabled power strip, you're going to need some parts. The first thing you're going to need is some hardware. This thing's driven by a Raspberry Pi Model B computer working in conjunction with a relay board from Fidgets.com. You're also going to need a dual USB charger, a 10 amp thermal circuit breaker, a 4 gigabyte SD card, and a snap-in IEC male jack. Next, you're going to need some software. The relay board from Fidgets.com comes with software and drivers that will give you the ability to invoke web services commands on the Raspberry Pi and access your relay board. So if you're a programmer and that's the level of access you want, that's the route you should take. Just download an operating system image file from raspberrypi.org, download the software and drivers from Fidgets.com, and code up your own interface. If you want to be able to control this thing from a web browser, you want a super simple interface to start with, get the Newbound web software, the Powerstrip software from Newbound.com. You can get it as an SD card or an image for an SD card, or even as a jar file if that's the way you want to go. We recommend download the SD card image, burn it onto your SD card, and you're ready to go. You're going to need some nuts and bolts to hold the various parts of this thing together. You want 3mm diameter nuts and bolts, 16 hex nuts, and you're going to want 6 2-centimeter long bolts, and you're going to want 8 1-centimeter long bolts. You'll also need 4 electrical outlets, just the standard outlets you would install on the wall in your home. You're going to need some cables. First, take a regular Ethernet cable and cut off about 6 inches off of one end, and then trim back the outer shielding off the cut end by about 1 inch. You're also going to need a Cat5e Ethernet jack that you can attach to the end of the Ethernet cable you just cut up. Next, you're going to need a spliced USB-Y connector. Basically, what you're going to do is you're going to take the cable that came with the relay board from Fidgets.com, and you're going to cut 8 inches off of either end of it. One end is a USB-A, and the other end is a USB Mini B. You're also going to need a third end. So you're going to take another USB cable, as long as it's got an A ending on it, and cut 8 inches off the end of that. You'll want to trim 1 inch of the outer shielding off of all 3 ends. You're going to take one of the USB-A ends and trim back the outer shielding on the red and black wires about 1/2 inch. You're going to trim the green and white wires off the other USB-A end, also about 1/2 inch. You're going to trim all 4 red, black, green, and white on the USB Mini B end. Basically, what you're going to do is attach the exposed ends of the same colors of all 3 wires. You're going to want to bend back all of the shielding wire that's inside there and just expose those wires, and twist together the individual red wires, black wires, the exposed green wires and white wires. And then you're just going to use some electrical tape to insulate each of those connections. So you'll start with one twisted pair and wrap it, and then fold in the next one and wrap it, and make sure that none of the twisted pairs are able to touch each other or are exposed in any way. And just wire that up real good. Use a twist tie or a zip tie to attach all 3 cables about 1.5 inches from the end. It's a good idea to use a different colored USB cable for the second USB-A end, the one you're going to use for the red and black wires. That's your power end. and you want to be able to recognize it later. So if you use a different color, or if it's the same color, wrap a little bit of electrical tape around that end so that you know that that end goes for power instead of for data. Next, you're going to need some 3D printed parts. These parts provide the basic framework for the device, and everything screws in or snaps in to the printed parts. Finally, you're going to need a whole bunch of wire. What I did is I just bought myself a 9-foot extension cord, 14 gauge, and I chopped it up into a whole bunch of parts. Basically, chop it up into 8 9-inch segments, and you'll need to chop the black wires from inside of it some additional amount. Basically, you only need 6 of the green wires. You need 6 green-inch wires. Trim them to a 1/4 inch on one end and 3/4 inch on the other end for 5 of them, and the last one, trim it to just 1/2 inch on both ends. For the white ones, you'll need 6 of the 9-inch segments, trimmed to 1/4 inch on one end and 3/4 inch on the other, and then an additional segment trimmed to 1/2 inch on both ends. For the black ones, it gets a little more complicated. What you basically want to do is you want to leave 4 of the 8 9-inch segments at 9 inches. You trim 1 to a 1/4 inch at one end and 3/4 inch at the other end. You trim 1 to 1/2 inch on one end and 3/4 inch on the other end. You trim 1 to 1/2 inch on one end and 1/2 inch on the other end. And you trim 1 to 1/2 inch on one end and 1/4 inch on the other end. 3 of the black segments you're going to cut in half so that they're 4.5 inches each. You're going to trim 2 of those to a 1/4 inch on one end and 3/4 inch on the other end. You're going to trim another 2 of them to a 1/4 inch on one end and 1/2 inch on the other end. You're going to trim 1 of them to 1/2 inch on one end and 3/4 inch on the other end. And you're going to trim the last one to 3/4 inch on one end and 3/4 inch on the other end. The final black 9-inch segment you're going to cut at the 3-inch mark. So it's 3-inch segment and a 6-inch segment. The 3-inch segment you're going to trim to 1/2 inch from the end, and the other end you're going to trim to a 1/4 inch. The 6-inch segment you want to trim to a 1/4 inch on one end and 3/4 inch on the other end. And the very last thing you're going to need are some 4-port wire connectors, 6 of them. Okay, let's stick some wires into connectors and then we can actually start building some stuff. First, start with the white wires. Grab 2 of the 4-port connectors and shove all of the 1/2 inch ends into them, except one of the white wires. Set one 9-inch white wire with a 1/2 inch on one end and 3/4 inch on the other end. Set that aside and plug the rest of the 1/2 inch ends into the 2 connectors, using the wire that has 1/2 inch trimmed on both ends to connect the 2. You're going to do the exact same thing with the green, except there's one less wire. Still, you want to set aside one of the 1/2 inch on one end, 3/4 inch on the other end green wires, and connect up the other wires in the same way as the white ones. Black ones are a little bit tricky. You want to set aside a number of the wires. First, connect your 2 remaining 4-port connectors with the one black wire that's 1/2 inch on both ends. Next, look for the wires that are 1/2 inch trimmed on one end and a 1/4 inch on the other. You're going to want to grab 2 of the 4.5 inch ones, the 3-inch one, and the 9-inch one. You're going to plug in the 1/2 inch side into the remaining ports on the connectors. Now, grab the black wire that's trimmed to 1/2 inch on one end and 3/4 of an inch on the other end, and put that into one of the remaining connector ports. There should be one port left open on your port pair here. Now it's time to wire up the Ethernet cable. Basically, we're going to take the Cat5 jack and stick it onto the exposed end of the cable. There should be instructions on the box that the jacks came in, but basically there is a color scheme on the jack itself. There's an A scheme and a B scheme. You're most likely going to be using the B scheme because most cables use B, but you can tell by looking at the edge of your cable. If one of the sides, one of the last wires on either side of the cable, and the clear plastic end, is orange, you know you've got B. Basically, you just want to match up the colors on the wires with the colors on the slots on the jack. You need to push down each wire into the slot as far as it can go. There's a tool for this. It's called a punch down tool. Use it. Basically, if you don't get this right, you're not going to have any Ethernet connectivity to your device. So all of those wires, all 8 of them, need to make nice solid contact with the metal in each of the slots. So push down each of the wires really good, and then put the cap on, and you're ready to go. At this point, you're going to want to test the cable you just made. Just plug it into your Raspberry Pi, plug an Ethernet cable into the jack and into your router, and make sure that you can access the Raspberry Pi from another computer on the network. Typically, I use SSH and just SSH over to the device and make sure that I can access it. If you are able to do that, then you're good to go. Now, grab the 3D printed part that looks like this. This is the part that we're going to mount the Raspberry Pi to, and also we're going to mount the USB charger to this piece. Now flip it over and you'll see some indentations approximately in the shape of a hex nut. And we're going to put hex nuts in those indentations. You might need to push down a little bit with a pair of pliers to get it to sink in there nice, but it should fit nice and snug, and you're all set. Now, grab the IEC male jack and the loose white wire and the loose green wire, as well as the 4.5 inch black wire that's trimmed to 3/4 inches on either end. And what we're going to do is we're going to basically attach these wires to the prongs that stick out on the inside, at the end of the jack. So these are what's going to be bringing in the power to our device. Basically, just starting with the black wire, look for the prong that's marked L. That means live. Thread the end of the black wire through the little hole and curve it around. Pull it about halfway through so that half of the exposed wire is through the hole. And then use a pair of pliers or something to twist it back and up against itself, so that it forms a nice tight connection. Do the same thing for the white and the green wires using the 3/4 inch ends. Make sure that the wires end up pointing out away from the prongs on either side, left or right, and in the center pointing up, so that basically the exposed wires are as far away from each other as possible. Make sure there aren't any straggling strands that might cross over. That's what's known as a short, and that's a bad thing. Now, grab the 3D printed base to the unit and pull all 3 wires through the IEC jack mounting hole on the outside of the base, and pull the wires then through the 3 holes on the inside of the mounting jack. thread all 3 wires through and then pull the wires all the way until the mounting jack snaps into the mounting bracket. The walls on the inside of the mounting bracket should keep all of the wires securely away from each other and prevent a short from occurring. Now just snap the cap onto the mounting bracket and you're good to go. You've got a nice clean mounting bracket with secure connections and no chance of a short. Now grab the circuit breaker, the 4.5-inch black wire with 1/2-inch trim on one side and 3/4-inch trim on the other side, and the bezel. What we're going to do is we're going to thread the black wire, the 3/4-inch length of it, through the prong marked 2 on the circuit breaker. And we're going to twist it just like we did with the IEC mount. We're going to do the same thing with the wire that's coming out of the IEC mount, but first we need to thread both of them through the circuit breaker cap. Then, once both of the wires are through the cap, twist the wire coming out of the IEC mount onto the prong marked 1 of the circuit breaker and insert the circuit breaker through the circular hole in the base. Then snug up the cap nice and tight and pop it into place, and that will hold the circuit breaker in place on the inside. Finally, put the bezel on the outside and twist that tight so that it holds the circuit breaker firmly in place. Directly next to the circuit breaker, there's a bank of 3 connector-sized slots. Grab the bundle of black connected cables and find the connector that has an open port and push that connector into the first of the 3 slots. Now grab the wire, the black wire that's loose that's coming out from behind the circuit breaker, and plug that into the open port on the connector. Now do the same thing with the green bundle of wires. Push it into the second slot and grab the green wire coming out of the IEC mount and plug that into the connector, and finally do the same with the white wires and the white wire coming out of the IEC connector. Grab the 3D printed mount that you snapped the hex nuts into earlier and pop it into the similarly shaped indentation in the base of the unit. It should pop in there very snug and shouldn't want to come loose very easily. You want to push at all the edges and make sure that it snaps all the way in. When it stops making a crunchy noise when you press it, you know it's all the way in. Next, grab the USB charger and snap it into the grooves on the mount. Now find one of the black wires with the 3/4-inch trim on the end and bend the end into a bit of a hook. You can then thread that through the hole in the prong of the USB charger and pull it up and out and through. Pull it again about halfway so that the exposed part is about halfway through, and then use a pair of pliers to twist it in real tight in place. It doesn't need to look pretty, it just needs to be tight and hold. Do the same with the 3/4-inch exposed end wire, white wire, on the other prong. Finally, just snap the cap cover in place and your USB charger is ready to go. Now grab the Raspberry Pi, the SD card, and 2 of the 1 centimeter long bolts. Insert the SD card into the Raspberry Pi and mount the Pi onto the base using the bolts. Plug the Ethernet cable into the Raspberry Pi and snap the jack into the mount hole on the base. Insert the USB-A data end of the Y cable into the Raspberry Pi. If you want to connect to your device wirelessly and you have a small Wi-Fi USB plug, now would be the time to put that in as well. Next, pull the loose green and white wire connectors through the jumble of wires to the other side, across to where the other bank of connector slots is. Pull the loose wires away from the device and so they're out of your way. Now it's time to prepare the relay board mount. Grab the mount, the relay board, and the screws and spacers that came with the board. On the underside of the mount are 4 hex nut shaped indentations, and we're going to press hex nuts into those indentations the same way we did with the other mount. Now pop the relay mount firmly into place. It should hold the other mount in place underneath it as well. Make sure that the white and green and black wires that you pulled through to the other side are underneath the lip of the relay mount. Push it in nice and firm until you don't hear any more pops and cracks. Then you know it's firmly in place. Now grab the relay board, one of the spacers, and one of the bolts. Slide the bolt through one of the mount holes on the relay board and slide the spacer onto the bolt, and then drop that corner into one of the holes on the relay mount. The relay should be facing so that the green connectors are next to the bank of connector slots, and the power, the USB cable, is pointing off the other direction. Don't tighten the screw all the way, just tighten it a little bit so that you still got plenty of play on the board. And now you can slide the spacers underneath the other holes one at a time and put in the screws. And once all of the screws are in loosely, then go around and tighten all 4 nice and tight. Now it's time to connect the USB mini end of the Y cable into the relay board. You can also grab the USB micro cable for the power on the Raspberry Pi. You can go ahead and plug that into the Raspberry Pi and also into the bottom slot of the charger. Grab the 9-inch loose black wire and insert that into the on the relay board on the terminal marked 0C and tighten that up real good. Then pop in the black connector into the first slot in the connector bank there and attach the remaining black wires into the slots marked 1C, 2C, and 3C and tighten those up as well. Once you've got those in there, grab the 4 remaining loose wires and feed them into the terminals marked NO, starting with the longest next to 0C in the NO slot and working your way towards the shortest on the other end. Once you've got all those in there nice and tight, bend the wires up so that they reach towards the sky, and you're going to want to pop in the green connector into the middle slot and the white connector into the final slot. Finally, you want to plug the USB-A power end of the Y cable into the power supply. Okay, now for the most difficult part of the entire assembly process, and that is getting the hex nuts into the shell. Specifically, what looks here to be the bottom, it's actually the top of the shell because it's flipped over. The ones down there are just really awkward to get at. you may need to use something long and flat with a hammer to kind of pound those in there. But it's very important that they get in there and they get in there flush. The ones on the top, you may want to use a little bit of super glue around the edges of the hex nuts once they're in. They're easier to get in, but unlike all of the other hex nuts in this project, there's nothing really holding these in place except friction. So a little super glue can't hurt. Now once the super glue is dried, flip the shell over and slide it on top of the base. Make sure that there aren't any wires sticking out the bottom, and make sure that all of the loose wires are sticking up out of the top. You should have 4 white ones, 4 green ones, and 4 black ones. Now flip the whole thing over and grab the 6 1-centimeter bolts that are left. And starting at one corner, just screw them in using an Allen wrench. They should go all the way in. They should be at least flush with the base, if not a little bit below the surface. Flip the whole thing over and give each of the terminals on the relay board an extra tightening at this point. Just that little bit of jostling around that we did is enough to loosen some of the wires. Grab one of the outlets. The outlets have golden terminals on one side, and on the other side there are silver terminals and also a green terminal. You want to connect the black wires to the golden terminals and the white wires to the silver terminals and the green wires to the green terminals. So grab one of the white wires that is loose and bend it into a hook. Make sure that the hook goes clockwise when you set it over the screw on one of the silver terminals. Then just tighten it up and do the same thing with the green. Bend it into a hook, fish it over, tighten it with the screwdriver. Then turn the outlet around and do the same thing with the shortest of the black wires. It's important to get the black wires in order. You want the one that's coming out of 3C on the relay board. Just fish that over, tighten it up, and then you're ready to mount it onto the shell. The screws that came with the outlet will fit into the holes on the shell, and you can just screw it down. You don't want to get it too tight though, because you're just screwing into plastic, and if you keep screwing after it starts to be snug, you're just going to strip the plastic. It's not important that these are super tight, because we're going to put the cover on top of that, and that's going to hold these in place as well. Repeat this process for the remaining 3 outlets, making sure that you use the next black wire each time. Now, just pop on the cover, screw in the 6 remaining bolts, flip it over, pop on some rubber feet, and you're done. And now you can turn stuff on with your phone.